if I present here, let's see. This is another amino acid. If I present, right. This is another amino acid. This is in fact another amino acid. What amino acid this is commonly called? This is called histidine. So definitely we shall call this S-histidine. So this is S-histidine. So what happens in this case? Let me, if I draw this structure, this complete structure in a different color, and I present this in a different color, just to make a variation in that. What happens next is very interesting to see that this amino acid is converted into a very interesting molecule. If I present different enzymes work on this, different enzymes. Let me, if I present which enzymes work, first of all, there is another enzyme work which called decarboxylase. Decarboxylase. This enzyme work, right? So in next, what happens when decarboxylation takes place? Carbon dioxide removes from this. So no, sorry, not decarboxylase. It is the reductase, which reduces this carbon dioxide into, sorry, this is the reductase works, which reduces this one, all right, and removes deaminase. 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 Deaminase means which removes ammonia. NH2 from here and a hydrogen from here generate a double bond at this position, right? Reductase reduces this one, and then is the transaminase. Transaminase. Transaminase enzyme works on this. So look at here, these enzymes work on this, and the structure converts into, first of all, what happens? First of all, what happened? Reductase reduces this one, right? So let me first, if I kill this, so it converts that into this one. First of all, I'm going to present this stepwise. It is the first reductase work, reduces this carboxylic acid into primary alcohol. Then deaminase work. Deaminase removes NH2 from here and a hydrogen from here. Deaminase means removal of ammonia. NH2 from here and hydrogen from here, ammonia shall be lost. So here we shall get the loss of ammonia and we shall get a double bond at this position. Next is transaminase. Transaminase which convert this hydroxyl into amino functional group. So this has been generated in fact. So these are the, this is another amino acid and this is a pyrrolidine alkaloid. You see, this is a 5-membered ring. Now these two gets coupled to each other. And what happens next? Here, one brominase is the enzyme which substitute hydrogen from these two positions by similar procedure. So it is not going to be completed. Time is over. So we shall, I shall present this in today when we are having lectures. Today practical hours. So we are going to log in by 12:15. So I shall very quickly present the biosynthesis of this, and then we shall switch over to our practical hours.